Welcome to this session on wireless networks and WLAN technologies. In this module, we'll explore the fundamentals of wireless communication systems and take a closer look at the wireless local area networks or WLANs. By the end of this lecture, you will have a solid understanding of how wireless technologies have evolved and how wireless LANs enable seamless connectivity in modern communication systems. Let's begin our journey into the world of wireless networking. Here is an overview of what we'll cover in this session. First, we'll begin with the basics of wireless networks, understanding what they are and how they operate. Next, we'll explore WLAN technologies including standards and protocols that form the foundation of wireless LANs. Then, we'll look into the setup and configuration of WLAN systems, providing practical insights into how these networks are deployed. Following that, we'll discuss the performance and optimization techniques to enhance network efficiency and reliability. And finally, we'll touch on some of the emerging trends in WLANs that are shaping the future of wireless communications. Let's get started with the basics of wireless networks now. Each type of these networks has a unique purpose depending on range, infrastructure, and application needs. Let's now explore the key components and architecture of wireless local area network. First, we have the access points, which are APs. These act as bridges between wireless clients and the wide network. They manage wireless communication within a defined range and provide internet access to the connected devices. Second are the clients. These include devices like smartphones, laptops, and tablets that connect to the wireless network using access point to access online resources and services. Third, we have wireless NICs or network interface cards. These are essential hardware components embedded in the client devices. They enable communication over a wide wireless network by converting digital data into radio signals. And lastly, the distribution system. These systems link multiple access points together, allowing seamless communication across the entire network. It ensures efficient data transfer and manages the traffic effectively. Together, these components create a robust and scalable wireless network infrastructure. Now let's look into IEEE 802.11 standard, which defines the protocols for wireless local area networks. First, the 802.11a, B, G, N, AC and AX standards. Each version of these 802.81 family provides different data rates, ranges and frequency capabilities. For example, 802.11a, which was one of the earliest, while 802.11ax, also known as Wi-Fi, offers significantly improved speed, capacity and efficiency. Knowing these standards helps in selecting the right technology for specific needs. And second, let's know about the frequency bands. Wireless LAN typically operate on 2.4 GHz and 5 GHz bands. The 2.4 GHz band offers great range but may suffer more interference, while the 5 GHz band provides faster speeds and less congestion, and these are ideal for high performance tasks. Understanding these standards and frequency differences is a key to optimize the wireless network and design performance. Security is a crucial aspect of any wireless network. Let's look into at the three main security protocols used in wireless LANs. We have WEP, which is Wide Equivalent Privacy. WEP was the original security protocol, but now it's considered outdated and insecure. It uses weak encryption and it's vulnerable to attacks, making it unsuitable for protecting modern networks. And the next version is WPA and WPA2, which stands for Wi-Fi Protected Access. These protocols offer much stronger encryption and improved authentication compared to WEP. WPA2 in particular has been the standard for many years due to its robust security features. Finally, we have WPA3, the most recent and advanced protocol. WPA3 provides enhanced protection against brute force attacks and offers the better encryption methods for both home and enterprise networks. It ensures safer and more and most efficient wireless connections. Choosing the right security protocol is essential for protecting sensitive data and ensuring reliable network access. When setting up a wireless network, having right hardware is essential to ensure reliability, performance, of course connectivity. Routers and switches form the backbone of any network. Router manages the flow of the data between networks while switches handle communication within the same network. Together, they provide a stable and efficient infrastructure for the data transfer. Networking cables like Ethernet cables are still important in wireless networks. They connect critical devices such as routers and switches and of course ensure fast and stable data transmission between them. Antennae are key to enhance the wireless signal distribution and reception. They help extending the network's range and improves overall performance by ensuring that the signals are transmitted and received clearly across the coverage area. Each of these components play a vital role in building a robust and efficient wireless networking atmosphere. When deploying a wireless network, ensuring software compatibility is just as important as having the right hardware. The operating system compatibility is a key factor. The hardware we choose must support various operating systems to allow seamless integration and consistent performance across different platforms and environments. Equally important is the driver installation. Drivers act as bridge between the hardware components and the operating system. Proper installation of these drivers ensure that the devices like network cards and adapters communicate effectively and perform optimally within the network. Together, these software requirements help maintain a stable, efficient, and compatible wireless networking environment. Signal interference and bandwidth are the two of the most critical factors influencing the performance of wireless networks. Let's have a detailed look and role of their role and their importance. So coming to the definition of signal interference. It occurs when unwanted signals disrupt the transmission and reception of wireless communication. It has also the capacity to degrade the signal quality and can come from various sources like other wireless devices, physical obstacles, or even electronic components that are used in the system. There are basically three types of interference: co-channel interference, adjacent channel interference, and non-Wi-Fi interference. So, co-channel interference occurs when multiple devices use the same frequency channel, whereas the adjacent channel interference occurs when the signals from nearby channels itself overlap. From the devices like microwave ovens or cordless phones or Bluetooth devices, there is a chance for occurrence of non-Wi-Fi interference. And the impact of this particular interference on the wireless networks is tremendous. It has a capability to reduce the signal quality, to lower the data throughput. There may be drop in the connections, and of course the security concerns. Proper interference management is essential for network reliability and performance. The techniques like frequency planning, spectrum analysis, dynamic channel allocation help to minimize this particular interference. The second very important parameter that has to be taken our concern is the bandwidth. Bandwidth is a maximum data rate that can be transmitted over a wireless channel. It is measured in terms of bits per second. The importance of the bandwidth or measuring the bandwidth in the wireless networks is to determine how much data can be transmitted at once. It of course affects the speed and capacity of the network. The allocation of the bandwidth must be shared among all the users or devices in the network. There are main important factors that affects the bandwidth or the channel width, how wider are the channels are, the technology standards that are being used, and the congestion that exists in the networks. Moreover, the bandwidth enables fast streaming, smooth video calls, and very fast downloads of the files. And this is of course very crucial for maintaining quality of services in applications like VoIP and gaming. There is a need to support IoT and high density environments. Let us now look into the optimization techniques. The roles and importance of signal strength, load balancing, and channel selection in wireless networks are the factors that are playing a key role to maintain the optimization or the optimal performance and user's experience. Signal strength refers to the power level of the wireless signal received by the device, typically measured in dBm. Stronger signals provide more reliable connections. The main role is to determine the quality and stability of the connection, which affects the data transfer speed and error rates. It also influences how far a device can be from wireless access point while still maintaining a connection. There is of course a very important point of the importance of signal strength. Strong signal strength leads to better throughput and fewer drop in the packets. Weak signals result in slow speeds, increase in latency, and frequency disconnections. crucial for applications that require real-time data like video conferencing or online gaming. So this can be optimized by proper placement of access points, use of signal boosters or mesh networks, and minimizing the number of obstructions that are in the network while the data is being transmitted. And the second very important point is load balancing, which is defined as the distributing. It refers to the distribution of the network traffic evenly across the multiple access points or channels to prevent congestion. The main role of understanding load balancing is it avoids overloading a signal access point with many users. It ensures fair access to bandwidth among users and devices, and it improves overall network efficiency and user experience. And the importance is it prevents the performance degradation during high user data density. It allows a scalable and reliable network performance, and especially critical in enterprise or campus networks with multiple users. And the third very important factor is channel selection. It refers to choosing the best wireless frequency channel within the range of 2.4 GHz or 5 GHz band for communication to minimize interference and maximize the performance. The main role is it reduces the co-channel and adjacent channel interference. It ensures better data rates and lower latencies. It has a capacity to enhance the signal clarity and network stability. There is an importance to understand or to mainly concentrate on the channel selection. It is critical in crowded environments. The smart channel selection boosts throughput and reduces the packet loss. It of course helps to achieve more reliable connectivity and user satisfaction. And these are the very important points that are helpful for the optimization. 5G integration in wireless networks, enhanced connectivity and speed improvements. The integration of 5G technology into wireless networks marks a significant leap forward in mobile and broadband communication. Let us now understand how it transforms connectivity and speed. So coming to the enhanced connectivity, it refers to the ability to connect more devices simultaneously with a stable and low latency communication, which is useful for modern applications. So the key improvements that are with 5G are massive device support, because it is capable of supporting massive machine type communication, enabling millions of IoT devices per square kilometer to get connected. And it is mainly ideal for smart cities, factories, agriculture, and autonomous systems. And second important improvement is latency, low latency. Latency was reduced as much as 1 millisecond, enabling real-time applications like autonomous vehicles. Greater network reliability. The enhanced network scaling allows dedicated slices for specific applications, ensuring reliable and tailored connectivity. The better coverage and mobility can be used using 5G networks, which use a combination of low, mid, and high band spectrum to provide wide coverage, better indoor penetration, and high capacity in the dense areas. Coming to the speed improvements, it can be defined something like the 5G dramatically increases data transfer speeds, enabling faster downloads, faster uploads, and faster streaming with minimum buffering or the delay. And the speed gains with 5G parameters can be classified as the peak data rates, that data rate is increased, and bandwidth was efficiently being used, and faster uploads, data is being able to get uploaded very fastly. Now coming to the IoT and smart devices. So today every person or everyone is speaking about IoT because its applications also. So the listed in front of you are a few of the applications that are basically being used in IoT using smart devices: home automation, industrial applications, and healthcare systems. Thank you all. Hope you enjoyed this session.